friends, how today's video my approach to a RMN question. The question states that if omega is equal to integral of 0 to infinity of sine into bracket Cschx x dx, so we are told to find the value for the expression above. Solution. Now let's recall this. Recall sine x. Recall that sine x action, this not shine, action x. Recall that action x is equal to log x plus root of 1 plus x squared. And you should recall that Cschx x is also equal to 2 over e raised to the power of x minus e raised to the power of minus x. So let's start our simplification of sine into bracket cos x. So our action Cschx x will now be equal to what? Will be equal to log into bracket 2 over e raised to the power of x minus e raised to the power of minus x plus root of 1 plus 2 over e raised to the power of x minus e raised to the power of minus x. Everything will be squared. Don't forget that. Squared. Now let's continue. What I did here was that I replace x by what? By Cschx x, which is what? 2 over e raised to the power of x minus e raised to the power of x into what? Action x. Do you get what I'm saying? So instead of writing x in action x, so I use what? Cschx x, which is what? 2 over e raised to the power of x minus e raised to the power of minus x. I'm sure you get what I'm saying. So let's continue the simplification. So after that, you say 2 squared will give you what? 2 squared will give you 4, and e raised to the power of x minus e raised to the power of minus x squared will give you us what? It will give us e raised to the power of 2x minus 2 plus e raised to the power of minus 2x. That's what it will give us. So let's continue. So our next answer is log into bracket 2 over e raised to the power of x minus e raised to the power of minus x plus root of 1 plus 4 over e raised to the power of 2x minus 2 plus e raised to the power of minus 2x. So let's continue our simplification. From the square root, don't forget that the common LCM will be what? E raised to the power of 2x minus 2 plus e raised to the power of minus 2x. That's our common LCM. So it becomes log into bracket 2 over e raised to the power of x minus e raised to the power of minus x plus the root of e raised to the power of 2x minus 2 plus e raised to the power of minus 2x plus 4. Everything over e raised to the power of 2x minus 2 plus e raised to the power of minus 2x. Close your bracket. So minus 2 plus 4 will give us plus 2. So our answer become log 2 over e raised to the power of x minus e raised to the power of minus x plus root of e raised to the power of 2x plus e raised to the power of minus 2x plus 2. Everything over e raised to the power of 2x minus 2 plus e raised to the power of minus 2x. If we should factorize e raised to the power of 2x plus 2, okay, plus e raised to the power of minus 2x plus 2. If we should factorize this, we are going to get this. We are going to get e raised to the power of x plus e raised to the power of minus x squared. So if you expand this, you're gonna get this. And if we should factorize e raised to power 2x minus 2 plus e raised to the power of minus 2x, so you will definitely get what? E raised to the power of x minus e raised to the power of minus x squared. So we are going to replace each by this. So let's continue. The next one is log into bracket 2 over e raised to the power of x minus e raised to the power of minus x plus root of e raised to the power of x plus e raised to the power of minus x squared over e raised to the power of x minus e raised to the power of minus x squared. So square will cancel root, so it's now become normal fraction. Log into bracket 2 over e raised to the power of x minus e raised to the power of minus x plus e raised to the power of x plus e raised to the power of minus x over e raised to the power of x minus e raised to the power of minus x. Yeah. So we have common LCM. So our work become what? Log into bracket 2 plus e raised to the power of x plus e raised to the power of minus x, everything over e raised to the power of x minus e raised to the power of minus x. So close your bracket. Now integrating the above expression. So we want to integrate this now. Integrating the above expression, the integral starting from 0 to infinity of log 2 of log 2 plus e raised to the power of x plus e raised to the power of minus x over e raised to the power of x minus e raised to the power of minus x dx. We can do this one. So we are almost through. Multiply the numerator by e raised to the power of minus x and multiply the denominator by e raised to the power of minus x. So we have the integral of 0 to infinity of log e raised to the power of minus x multiplied by 2 plus e raised to the power of x plus e raised to the power of minus x over over sorry over e raised to the power of minus x into bracket e raised to the power of x minus e raised to the power of minus x. So close your bracket, close this one too. Sorry. So close your bracket. If you say that e raised to the power of x, they can cancel each other, so that's why I multiply the both numerator and the denominator by e raised to the power of minus x. So our integral become 0 to, okay, starting from 0 to infinity of log 2e raised to the power of minus x plus 1, because e raised to the power of minus x times e raised to the power of x will give us 1, plus e raised to the power of minus 2x, everything over 1 minus e raised to the power of minus 2x dx. So let's make a u sub. Let e raised to the power of minus x be equal to u, and our dx will now be what? We have minus e raised to the power of minus x dx is equal to what? Is equal to du. So dx will now be what? So dx is now equal to minus du over e raised to the power of minus x. And don't forget that e raised to the power of minus x is u. So dx will now be what? Minus du over u. So replacing that e raised to the power of minus x by u over du. So that's our dx. Now replacing e raised to the power of minus x by what? By u. So we have, okay, and our limit e raised to the power of minus infinity will give us 0, and e raised to the power of minus 0 will give us 1. So we have integral from 1 to 0 of log 2 u plus 1 plus u squared over 1 minus u squared multiplied by our minus du over u. So we will now interchange the limit. That will be what? From 0 to 1, because of this minus that is the front of the u over u. So the minus will now what? Will now evacuate, and we have integral from starting from 0 to 1 of log u squared plus 2u plus 1 over 1 minus u squared multiplied by 1 over u du. So don't forget that u squared plus 2u plus 1 is equal to 1 plus u squared. And don't forget that 1 minus u squared is equal to 1 plus u multiplied by 1 minus u. So we are now going to apply this into the u squared plus 2u plus 1 over 1 minus u squared. So we have integral starting from 0 to 1 of 1 over u log 1 plus u squared over 1 plus u multiplied by 1 minus u du. So 1 plus u, we cancel 1 plus u. So we have integral starting from 0 to 1 of 1 over u log 1 plus u
over 1 minus u du. So we are almost through, please. We are almost through. So using the log rule, if we have log a over b is the same thing as log a minus log b. That's what we do there. So we have integral starting from 0 to 1 of 1 over u log 1 plus u du minus integral starting from 0 to 1 of 1 over u log 1 minus u du. So I will recall some power series to you now. Some series. Don't forget that log 1 minus u is equal to minus sum of k is equal to starting from 1 to infinity of minus 1 raised to the power of k u raised to the power of k over k and log 1 plus u. Oh, sorry, this is 1 plus u. This is 1 plus u, and log 1 minus u is equal to minus sum of k starting from 1 to infinity of u raised to the power of k over k. So we are going to replace log 1 plus u by the first one and log 1 minus u by the second one. So we have the integral starting from 0 to 1 of 1 over u multiplied by minus sum of k starting from 1 to infinity of minus 1 raised to the power of k times u raised to the power of k over k du. So this is now equal to the integral of sum is sum. So let's take out the sum and the constant out. We have minus sum of k starting from 1 to infinity of minus 1 raised to the power of k over k, the integral starting from 0 to 1 of 1 over u times u raised to the power of k du. du is now equal to minus sum of k starting from 1 till infinity of minus of minus 1 of minus 1 raised to the power of k over k, the integral of the integral starting from 0 to 1 of u raised to the power of k over u will give us what? U raised to the power of k minus 1, law of indices. U raised to the power of k minus 1 du. So the integral of u raised to the power of k minus 1 du will be what? So this will now be equal to minus sum of k starting from 1 to infinity of minus 1 raised to the power of k over k. So the integral of u is now becoming u raised to the power of k minus 1 plus 1 over k minus 1 plus 1. So put your limit 0 to 1. So you have minus sum starting from 1 to infinity of of minus 1 is the power of k over k of 1 over k squared of k. If you have u raised to the power of k minus 1, so that would be u raised to the power of k over k. Put your limit 0 to 1. So this is now equal to minus sum of k starting from 1 to infinity of minus 1 raised to the power of k over k of what? Multiplied by 1 over k, which is equal to sum of k starting from 1 to infinity of minus 1 raised to the power of k over k squared. So let's do the second one. Integral 0 starting integral starting from 0 to 1 of log 1 minus 0. Don't forget to put your 1 over u there. 1 over u du. So it's now equal to the integral of 0 of the integral starting from 0 to 1 of 1 over u multiplied by the sum of k starting from 1 to infinity of minus u raised to the power of k over k du. So bringing out the limit and the constant, we have minus sum. Okay, bringing out the sum and the constant, sorry, we have minus sum of k is equal to 1, starting from 1 to infinity of 1 over k, the integral starting from 0 to 1 of u raised to the power of k minus 1 du, which is equal to minus sum of k starting from 1 to infinity of 1 over k squared of 1 over k squared. So this is our integral. Let's start evaluating the sum. So we have the sum of the first one is what? Minus sum of k starting from 1 to infinity of minus 1 raised to the power of k over k squared, abi, yeah, minus sum of k starting from 1 to infinity of 1 over k squared. So this is now equal to the sum 13, the sum of k starting from 1 to infinity of 1 over k squared minus the sum, minus the sum of k starting from 1 to infinity of minus 1 raised to the power of k over k squared. So don't forget that the sum of k starting from 1 to infinity of 1 over k squared will give us what? It will give us pi squared over 6. This is now pi square over 6 minus the sum of k starting from 1 to infinity of minus 1 raised to the power of k over k squared will give us minus pi squared over 12 minus pi squared over 12. So this is now equal to pi squared over 6 plus pi squared over 12 is equal to pi squared over 4. Pi squared over 4. So this is our required answer to this question. Please comment, like, subscribe to my channel, and share to all your lovers or all your friends. So by doing so, God will bless you too. Amen. So omega is now equal to pi squared over 4. Pi squared over 4. Thank you.